Welcome back, and now that we've got a good basic understanding of the chemistry involved in biology, let's actually get into some biology and start talking about biomolecules. So I like to call it the magic of carbon because it really is the carbon atom and its ability to form four bonds that allows us to form the major groups of biomolecules that we'll talk about in this unit. So the carbohydrates, the proteins, the lipids, and the nucleic acids. So let's take a good look at carbon and see what about it allows us to achieve the great variety that we see in biomolecules. And the big thing is its valence electrons. So carbon has four valence electrons that allows it to form four bonds. So if we see in the diagrams here, it's just three different ways of showing the same thing in terms of carbon having four electrons. So on the left, the little E minus, so this shows all 6 electrons of carbon. There are 2 on the interior and 4 on the outside. The middle one, the Lewis dot one, I kind of like that because it shows us that yes, we have the ability to form 1, 2, 3, 4 bonds of those 4 unpaired electrons. And over to the right, it's going to show the same thing. The little red dots are just showing just the valence electrons there. So carbon and the fact that it has 4 valence electrons is key to our discussion of biomolecules. So if we look at these two very simple, probably the most simple biomolecules that we'll talk about, are actually not really biomolecules, but carbon compounds. If we look in the upper left, so this is methane gas. Okay, and as we can see, carbon with its 4 blue electrons would like to gain 4 more in order to achieve its octet. Hydrogen has 1 each to donate, and so it will make 1, 2, 3, 4 covalent bonds to form CH4 or methane. So another way that we can designate this is carbon in the middle, and we have 4 hydrogens around the outside, where each line, so when we look at these, each line here represents a bond which has 2 electrons in it. So if we add up the total number of electrons around the carbon, we have 2, 4, 6, 8. Each hydrogen has 2, and everyone is stable in terms of the configuration. Now in the lower right, we have ethane. So there's 2 carbons there. So if we look at it, there's 2 carbons and 6 hydrogens. So the molecular formula is C2H6. And again, each carbon is going to have 8 electrons through sharing, and each hydrogen will have 2. And so we get the bonding that we need to get those stable. And the diagram for this, another way of showing it, would look like that. So this gives you an idea of how we can take some very simple elements, carbon and hydrogen, and start to link them together into longer and longer chains. Well, as we do that, we can, if you look down the lower left here, here is if we take 5 carbons, we get pentane. So 1 carbon is methane, 2 is ethane, all the way up, and we get 5 pentane, and so forth. So some carbon molecules are just going to be chains. So when we look at the lipids, this will see very similar to what lipids are because they're long backbones of just carbon and hydrogen. We can also have branched chains. Okay, so if we look at isopentane right here in this carbon, we have another carbon branching off of it, so it's not just a straight chain. When we look at carbohydrates, we'll look at glycogen as a compound in our muscles that gives us energy, and those are very branched chains of carbon, and because it is branching, they're able to store a lot of energy that we can use for that. We'll also see cyclic molecules. So here's a very simple one down in the lower right-hand corner, cyclopentane. We'll also look at things like cholesterol, nucleotides, even some carbohydrates will form ring structures because of carbon's ability to form those 4 bonds. And the main thing that I want you to take away is if you look at each of these pictures, pick any carbon you want. Let's pick this one right here. And there are 1, 2, 3, 4 bonds around it. Pick any carbon on here and there will always be 4 bonds around it. That's critical to our understanding of making these larger biomolecules. So if it's just simple carbon and hydrogen here, we can get the long chains. What gives us all the variety? I mean, there are literally thousands of different compounds out there that have carbon and hydrogen in them, but what gives them their different properties, what gives them, makes them different from one another. And so the last thing that we'll look at in this clip is the functional groups. So I like to think of functional groups as the ornaments on a Christmas tree. So the carbon and hydrogen give us the Christmas tree itself. They give this long chain, but the functional groups are the ornaments that we hang on it to decorate it. So the functional groups give carbon backbones variety and different properties. So if we look at the first one here, the hydroxyl group, okay? Sometimes the hydroxyl group, you may see it better as just OH. This makes things alcohols. It also gives them the property of being soluble in water. So that's a way that molecules can be changed to be given a different property. The carbonyl group, right here, the C with a double bond O, we're going to look at some of those when we talk about carbohydrates. And one group are called the aldehydes. And you may have heard of formaldehyde, which is a preservative. There are also ketones. And in this group, you may have heard of acetone, that is sometimes used as fingernail polish remover. A very important one that we're going to look at is the carbonyl group. And the reason this is so important is this makes things what we call organic acids. So when we talk about lactic acid, citric acid, when we get into respiration, all of those will have this characteristic carboxyl group on them. The amino group. So the amino group is going to be very important when we talk about proteins, and because all amino acids will have this amine group. And because of its ability to gain a third hydrogen sometimes, they will make polar molecules in many cases. And the last one that we'll mention real quick is the sulfhydryl group over here, so SH. These are going to be important when we talk about proteins because they help and determine the protein structure, how the proteins fold and take their three-dimensional shape. So as you can see, if you can understand the idea that these carbon atoms, with their ability to form 4 bonds each, will give us these long chains, branching chains, and cyclic compounds, and then we take the functional groups and add those on, you can see where the vast diversity and variety of biomolecules comes from. So thanks, and we will be back with the next section shortly.